Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. So we continue to our chapter 3.2 DNS and AD Integration. So the objective for this chapter is to explain the usage of AD integration zone. This is outline, but how we will cover for this chapter is introduction of DNS and AD integration, benefits of AD integrated zones, replications, transfer, and troubleshoot DNS and AD configuration. So introduction DNS and AD integration, this is the classic implementation. One primary server stores the only copy of the primary zone. So while secondary server maintain the redundant copies of the zones. So they are a weakness, which are they will not able to support the DNS zones and respond to queries for records in those zones and length period of time without able to contact the primary server. In fact, SOA records content that expired after fields that control this. Therefore, this problem can be avoided using the additive directory integrated zones. So, AD integrated zones are stored in the AD with every record represented as a AD object. Hence, now the DNS server with the AD integrated zone must also be a domain controller. So, AD integrated zones are all master copies of the zone, meaning that all the changes can be made to any instance of the zone. Replicate the changes or transfer the zones is classic terms. Windows Server 2003 use the AD replication engine built for the multi-master replication, but for our syllabus we use the 2019. This also means that the failure of any DNS server responsible for the zone does not incur any downtime for the DNS system as a whole, no matter how long remains down, providing that more than one domain controller was configured in as a DNS server. The DNS information can be stored either in the domain directory partition or in the new applications directory partition. The application partition allows the better control on how application data stored in a directory is replicated to another domain controller. So now we can control which domain and forest server should receive in application information separately from regular AD application, and application partition data is compiled into the global catalog service designed primarily to speed up the usage search for the other users folder and printer. This reduces the DNS application overhead while still using the anti-replication mechanism, thereby maintaining only one data replication scheme in our infrastructure. So DNS zone in the Active Directory. So storage method configuration from DNS management control. We have all the DNS server in the AD's forest, all the DNS servers in AD domain. All this is specified in the code following the application directory partitions, and all this is in the AD domain. So for the three up here will be in the partition used for the store zone in the application partition, and the tool designed to view a record in the DNS console and DNS CMD. But for the all DC in an AD domain will be in the domain partition, DNS console, and AD user. Okay, you can back to the original slide later. You can see. So for benefit AD integrated zone, first is no single point of the failure. So any changes made by using the dynamic update protocol can be made to any server that hosts by an Active Directory integrated zone rather than to a single server. A fault tolerance or the Active Directory integrated zone are primary zone. Therefore, each of the domain controller that hosts the Active Directory integrated maintains its zone information. The third one, where the single replication topology zone transfer occur automatically as a part of Active Directory replications, eliminating the need of the configure replication for the DNS and Active Directory separately. And the last one is secure the dynamic updates. You can set the permission on zones and records within those zones. Also, updates that use the dynamic update protocol can come only from the authorized computer. Next is delegating zones. So a zone starts as a storage database for a single DNS domain name. So if the domain names are added below the domain used to create the zone, this domain can either be a part of the same zone or part of another zone. For example, once the subdomain is added, it can be then managed to include the as a part of original zone record and delegate away to another zone create to support subdomains, something like this. You can see here Microsoft have a www or dev Microsoft, right? Zone replication and transfer. So for zone transfer, it has a process which the DNS server interact to maintain and synchronize the authorized name data. Because of the important role that plays in the DNS, it is intended that they be available from more than one DNS server on the network to provide availability and fault tolerance when resolve the name queries. Zone transfer are required to replicate the synchronize all the copies of the zone used at the each server configured in for the host zone. When structuring the zones, there are several good reasons to use additional DNS zone application. First, provide a zone redundancy to enable the DNS names in the zone to be resolved for the client if a primary server for the zone stop responding. Second, reduce DNS network traffic. For example, adding a DNS server to the opposing side of a low-speed wide area network. One link can be useful in managing the reduce the traffic network and the reduced load on the primary server for a zone. When a new DNS server is added to the network and configured as a new secondary server for existing zone, it performs full zone transfer ASFR ASFR to obtain the replicate a full copy of the resource record for the zone. For Windows, this is for the Windows 2000 server. So then as server support incremental zone transfer and revise a zone process to intermediate changes. For new Windows 2003 by default, it support the ISFR to reduce the amount of traffic generated by the DNS application. Scenario that require for the zone transfer. When starting the DNS service on the external server for the zone, and also the scenario for when the refresh internal times expire for the zone, and when the change made by primary zone and the notify list in configure. AD integrated application. Zone replication between the AD integrated zones does not need to be configured separately, so it will be since the AD integrated zone, then as they got LDAP object, they will replicate to another domain control as they were plain AD object. This replication is based on the AD sites. They can be divided by the two. First, intra-site replication and then inter-site replication. Intra-site replication is between domain controller in one site and automatically in every 5 to 15 minutes. But inter-site replication is between the bridge domain controller located different sites and possibly connected by the slow one link. It can be configured based on the available values, preferred replication schedule, replication transport, and other uh, fault. Okay, and other we can see the new nodes. Okay, and other factors. Right. So by applying the integrated AD zone, you do not need to worry about the AS zone replication separately from the AD application. We are not no need to plan, test, deploy the maintenance to this application scheme, and ISFR transfer are further split allowing the property based on the update. If the IP address of the code changes, so ASFR transfer entire zone, ISFR transfer the entire host resource record, and AD replications transfer just a new IP address. And since we introduced applications of the Windows Server 2003, the previous one, but now we use 2019, you can even specify precisely the which server IP address we get the replicated. Example, if we have 10 AD domain controller and uh, only okay, example, we have 10 AD domain controller and only 3 of them also DNS server, you can only need replicate this IP to the DNS servers. Next is zone transfer security. So the DNS also permit us to specify the servers allowed to participate in the zone transfer. So it can help to prevent undesired attempt by the unknown or unapproved DNS server to pull or request a zone update. So DNS notification, DNS notification implements a push mechanism for notify the select of secondary server, and use DNS notification only for notify the DNS server that are operating as a secondary server by a zone. For replication directory integrated zone, DNS notification is not needed, and configure notification. This can actually degrade the system performance, and also by causing the unnecessary additional transfer requests for the updated zone. So in the DNS security, okay, the DNS server maintain a critical two-way name resolution link between the private network and the internet, and such as such they are exposed to external access. This in turn means that they are like a target for external attack. So basically, DNS security is a two-side coin. So you need to make sure that Windows server is secure and perform the service. Then you can secure the service specific functionality, and all necessary network involved to the DNS solution should be disabled using the variety of software and hardware vendors in addition to being blocked on the firewall. So typically DNS related attacks as summarized here. First, we have DNS footprinting. So thief of the zone information allowed to attack to learn internal address and services. Or we have DOS, a massive amount of fake recursive query that are submitted to the server, making it too busy to service legit requests. IP spoofing, when a fake address obtained the DNS footprinting user make appear, then the attack inside the network and man in the middle of the direction. The same of DNS traffic that allow the attacker to take over the communication between the nodes, and this attack combine the DNS cache pulling, and which for result compromise and SD card added to the S cache. So that's all for this chapter. So hopefully you can understand DNS and AD integrated, and please answer the quiz after you done to watch this video. Thank you. Bye. Assalamualaikum.